Hello everyone, I'm Saurabh and I welcome you all to DigitalOcean's Deploy conference. So this is going to be a session around Kubernetes 201. In case some of you are looking for a beginner level session on Kubernetes basics, I would suggest you to watch our Kubernetes 101 session by my colleague Piyush Gupta, who has done a really fantastic job of explaining Kubernetes basics in a very simple and easy to understand way. Now, as a part of this Kubernetes 201 session, I would be walking you through some of the more intermediate Kubernetes concepts like autoscaling, Kubernetes RBAC, how resource quotas work, and also share some of the best practices to secure your Kubernetes cluster. So, on that note, let's start today's Kubernetes 201 session. So, a brief introduction about myself. I'm Saurabh Gupta. I'm senior developer advocate at DigitalOcean. I come with more than a decade of experience into development and cloud automation and DevOps, mostly working around container and Kubernetes technologies. So that's about me. In case during the session or post session you have any queries or you want to connect with me, you have my LinkedIn and Twitter handles over there, and you also have my email ID. So, yeah, feel free to reach out to me, and I would be more than happy to assist you. So, on that note, let's start. So, first things first, the agenda for the next 30 minutes. We are going to talk about some of the recent Kubernetes adoption trends across the globe. We will talk about Kubernetes autoscaling, RBAC, resource quotas, and finally some of the best security tips to secure your Kubernetes cluster. So let's talk a brief about why Kubernetes is so popular and what is the adoption trend across the globe for Kubernetes as an orchestrator for containers. So just got this data from an online tech forum called the New Stack. They have done some surveys, and yeah, these are the findings. So if you see, it says around 69% of organizations across the globe, they are using Kubernetes currently to manage their container workloads. And I think that's a big number. That shows the big popularity of Kubernetes across the ecosystem. Similarly, let's look at another data. So this gives you Kubernetes adoption in production and non-production environments by the size of organizations across the globe. So if we have a look at it, we see that around 25% of organizations use Kubernetes in production, right? And these are small organizations. Similarly, around 22% of organizations, and these are mid organizations with 100 to 1,000 employees across the globe, they use Kubernetes for running their production workloads. But an astonishing number of 34% of organizations, and these are large organizations with more than 1,000 employees, they use Kubernetes. So that shows that Kubernetes has come a far way since its inception, and it's quite popular as a container orchestrator across the globe, right? So definitely, I think Kubernetes dominates a container orchestration market, and as more and more organizations continue to expand their usage of containerized environments, right? Kubernetes is going to be the de facto standard for container deployment and orchestration in the future. Yeah, so just wanted to share those findings with you to show and see how popular is Kubernetes in our ecosystem. So now let's talk about Kubernetes autoscaling. So basically, we know that Kubernetes out of the box gives us the feature and functionality of autoscaling the cluster and the pods. So there are different ways to achieve this. Let's have a look how we can have autoscaling enabled within Kubernetes cluster, right? So basically, we have three different methods to achieve autoscaling in a Kubernetes environment. One, it's called cluster autoscaler. The next is horizontal pod autoscaling, or HPA as we call it. And the third one is vertical pod autoscaling, or VPA. So let's deep dive into each of them individually and see how they work. So let's first talk about cluster autoscaler, right? So a cluster autoscaler, as the name suggests, will work at a cluster level and scale up or down your cluster nodes based on certain parameters, right? So our cluster autoscaler does a periodic check and sees whether they are independent pods, and based on the demand, it can increase the size of a cluster. Similarly, it also does the check, and if it finds a particular node idle, it can schedule the pods running on that node to some other node and deallocate this particular node. So it works both ways. It can increase or decrease the size of your cluster. The only thing to remember with cluster autoscaler is that only a limited number of platforms, right, they support cluster autoscaler at this point of time. So in case you are using a managed Kubernetes service, you need to check with your provider if cluster autoscaler is available as an option. Now let's see how a cluster autoscaler works in real time. So this diagram shows you how a cluster autoscaler works in a real-time scenario. So there are 4 steps, and if you have step 1, have a look at step 1, right? So we have one node where we already have 2 pods which are kind of running, and then there are 2 more pods which are waiting to be scheduled. Now, as I said, there's in step 2 a cluster autoscaler which does a periodic check and finds that 2 pods which are in pending state could not be scheduled on this particular node. So what this cluster autoscaler now does is it spins up or provisions a new node, and in step 3, and if you look at step 4, now we have 2 nodes with each of them running 2 pods each, right? So that's a typical way how a cluster autoscaler works. It does a periodic check, and if it finds some pods which are in a pending state due to certain resource quotas missing or certain restrictions on the node, it provisions a new node or autoscales the size of the cluster. Now let's talk about the second method, which is basically horizontal scaling in Kubernetes environment. It's called HPA, or the horizontal pod autoscaler. So basically, HPA is a built-in Kubernetes feature that allows you to scale horizontally, which means it allows you to add more replicas to Kubernetes resources. It again does a periodic check, and the checking interval is around 30 seconds. So every 30 seconds it does a periodic check and looks for CPU and memory usage, or even your custom matrices, right? And based on the findings, it automatically increases or decreases the number of replicas. The only thing to keep in mind is that the HPA, right, the horizontal pod autoscaler, works only across objects that can be scaled. So objects that cannot be scaled, something like daemon sets, you cannot use an HPA. Now let's have a look how HPA, or horizontal pod autoscaler, works in real time. So we have a figure on the left, and then we have a sample YAML for HPA on the right. So if we see at the YAML, right, it says kind as HPA, horizontal pod autoscaler, and in specs we have something like spec.scale target ref. This HPA is working on a target of kind deployment, and if we see, we have something defined as min replicas, which is 3. It also says about max replicas, that says 5, and then the metrics that we are working on is CPU utilization, right? So it says target CPU utilization percentage, which is set as 85. So what that means is, as soon as a pod, or a deployment in this case, reaches a target CPU utilization of 85%, a new replica should be added. So how this works, if we'll just have a look at the diagram on the left. So we have a HPA, or the YAML file, right, the horizontal pod autoscaler, and as soon as it's find that the minimum threshold that has been defined is triggered, it works on that particular piece of resource. In this case, it's a deployment, and scales or add more replicas, right? So we have pod 1, pod 2, and then we can have up till like pod n. So this pod n would be the number of max replicas that we have defined. In our case, we have defined min replicas as 3 and max replicas as 5. So this basically means that at any point of time, there would be minimum 3 replicas of the deployment running, and at any point of time, there could be maximum 5 replicas that could be running. So that's about how a horizontal pod autoscaler works. It basically does horizontal scaling, which in Kubernetes definition means adding more replicas to the pods. Now let's have a look at vertical pod autoscaler, or VPA. Right. So in VPA, we basically have or ensure that there is a vertical pod autoscaling. So how does a vertical autoscaling works? In a typical Kubernetes environment, vertical autoscaling means that you either add or so now let's talk about the third type of autoscaling, which is basically vertical pod autoscaling, or VPA, popularly called as. So VPA basically operates based on certain CPU and memory thresholds defined for your pods, and can automatically maintain pod resources through the life cycle. So VPA basically has 3 different components: a VPA admission controller, there is a recommender, and an updater. And VPA operates in different modes like off, initial, auto, and recreate. So what are these modes and what are these components? Let's have a look. So this VPA recommender, this basically looks at different historical usage of CPU and memory for the pods, events like out of memory, and also specs of a deployment. And then it finds the best optimum values for a request and limits. These requests and limits can be raised or lowered, right? Both based on what definitions have been defined within the file in terms of threshold. So basically, recommender does a periodic check and gathers old data in terms of historic use of CPU and memory by the pods, and then provides a suggestion in terms of the best optimum value to run the resources. These suggestions are passed basically to the VPA updater. So updater is basically nothing but it looks at the current request rate and what is the suggestion in terms of from the recommender. So basically the updater compares the current and the recommended request and then passes it back to the admission controller. And then based on what kind of mode the admission controller is operating, we can have a new pod created with the suggested CPU and memory thresholds, or we can have the existing pods being recreated based on these thresholds. So we said we are talking about different operational modes of VPA. So when VPA is working in off mode, right? So the webhook does nothing, but it only suggests you the best optimum values in terms of CPU and memory. When we have VPA set to initial mode, it only applies these optimum values when a new pod is being created. It does not recreate the pods. Now coming to auto and recreate, when set to auto or recreate modes, a VPA can terminate and bring new pods with these defined optimum values in terms of CPU and memory. So based on what kind of mode you are running your VPA or vertical pod autoscaler, it can either give you suggestions in terms of best CPU and memory allocations for your pod, or it can create a new pod when set to initial, or it can recreate the existing pods if set to auto and recreate. So that's at a high level how autoscaling works within a Kubernetes ecosystem. We saw how our cluster autoscaler works based on increasing or decreasing size of the cluster nodes, how a horizontal pod autoscaler works uh, by working on the replicas of the Kubernetes resources, and how a vertical pod autoscaler works working on certain CPU and memory thresholds, and then either creating them or recreating the new pods as and when needed based on different modes. So now we will talk about how resource quotas work within a Kubernetes cluster. So by default, all resources in Kubernetes clusters are created in a namespace, which is called default, right? Default namespace. And potentially a pod can run with unbound CPU and memory request and limit if these are not defined. And I think this is where functionality like resource quotas come into picture. So basically, a resource quota defines a maximum total number of CPU and memory for a given namespace. So resource quotas work at a namespace level. Using a resource quota, you can define the limits on CPU and memory. And if a pod definition file or YAML fails to supply these resource and request limit, a pod creation will be denied. So basically, you will get a status code like 403 and a message that will explain you the constraint that has been violated in your pod creation YAML. So now let's have a look how resource quotas work in real time in Kubernetes. So as we can see on the left, we have a sample YAML file defining resource quotas, and then we have certain terms on the right. So as per this YAML, we define a kind called resource quota. And if we just look into metadata, right, into specs, so specs.hard, we have defined request in terms of request.cpu, request.memory, and we have also defined limits in terms of limits.cpu and limits.memory. So that's a way to check or keep a tab in terms of CPU request and memory across our namespace. So basically, when we talk about request.cpu, this is like maximum CPU millicores that are allocated for all the pods containers in namespace. Similarly, request.memory is the maximum memory that can be allocated for all the containers or pods within a namespace. And when we talk about limits, limits.cpu is the maximum CPU core limit for all the containers in the namespace, basically entire namespace. And limits.memory is a maximum memory limit for all the containers in this namespace. So using these limits, we can define the max CPU and memory request that can be allocated across a namespace, and also a minimum threshold for each pod in terms of limits.cpu and limits.memory that a pod should have within this namespace while creation. So using resource quotas, you can define the thresholds and make best optimum use of CPU and memory across a particular namespace. Now let's talk about Kubernetes RBAC, which is again a new feature by Kubernetes, and see how role-based access control works in a Kubernetes environment. So Kubernetes RBAC is basically a stable feature from release 1.8. So if you're using a version above 1.8 or any of the latest versions, Kubernetes RBAC would be available in your installed version. So RBAC basically follows the principle of least privilege. What does that mean is basically not everyone should have access to your Kubernetes cluster and across namespaces, right? So when we talk about RBAC, we have different components to it. What are the key elements of RBAC? Let's have a look. So there are basically three different key elements of RBAC. These are subjects, resources, and what we call as verbs. So subjects is nothing but a set of users, a group of users, or individual users, and us or processes, right? That want and to access or use your Kubernetes cluster. Resources would be all API objects available within the cluster. So a resource could be anything like a pod, a deployment, a node, a service, anything. And verbs are basically the actions that can be performed by the subjects on these resources. So in general, some of the verbs or example of verbs could be get, watch, create, delete, right? So basically CRUD operations and other actions that can be performed on a subject, on a resource by the subjects. So let's see how these elements, three elements of RBAC, work in real time. So if we just have a look at this picture, right, this diagram, so that shows you a clear relationship between subjects, resources, and verbs. So on the left, extreme left, we have subjects, which could be anything or any process, right? A user, a group of users, a team, or a set of process. So we have subjects like developer, administrators, different processes within the Kubernetes cluster, which are trying to access the resources. Talking about resources, we see a lot of resources mentioned across API resources like pods, config maps, autoscaler, deployment, replica sets, namespaces, nodes, etc. And then these subjects can perform different operations, which we call as verbs, right? So these verbs could be something like list, get, watch, create, delete, patch. So that's the way role-based access control can work in Kubernetes, making use of these three key elements. So basically, when we talk about RBAC, we have different resources available for RBAC, which can be defined. So there is a role, and attached to a role, there is a role binding. Similarly, we have a cluster role, and attached to a cluster role, there is a cluster role binding. So basically, a role connects your API resources and your verbs and can be used for different subjects, right? So the whole concept of a role is that it's binded to a single namespace. It works only across one namespace at a time. And a role binding is used to grant permissions to your subjects in a Kubernetes cluster. So a role is basically operating across one single namespace, and it can connect your resources and perform verbs or actions on top of them. And role binding is used to grant permissions to subjects for these particular roles. Talking about cluster role, a cluster role is similar to a role, just that the scope of operation is much more global. It basically applies across all namespaces within the cluster. And similarly, cluster role binding gives access to subjects or grants permission to subjects for a cluster role. So now let's have a look how role binding, cluster roles, and cluster binding work in a typical Kubernetes environment. So we just have two YAMLs we see on the left and the right. One talks about role example, and the second one is cluster role. So just having a look at role YAML on the left, we see that the kind has been defined as role. Then there is a metadata, and inside the metadata, we have a namespace which have been defined. In this case, it's default, but this could be any namespace where you want to use or extend this role. The name is pod reader, and then there is certain set of rules. So basically, as we said, right, the role binding. So it applies these rules on API groups, resources, and verbs. So what groups, what are resources? So in this case, the resources are pods. So the actions would be performed only on pods, and verbs in terms of what actions. So we can do a get, a watch, and a list. So if we just have a look at the cluster role YAML, right, on the right side. So the only difference between the role YAML and the cluster role on the right is that when we check metadata, we do not have a namespace. The namespace is omitted because cluster roles are more operate at a global level. They apply to all namespaces across the cluster. But if you look at the rules, we have the same set of targets, right? The API groups, the objects, the resources and the verbs. So in this case, the resources is basically secrets. So this cluster role is going to work on resources called secrets, Kubernetes secrets. And in terms of verbs or actions is you can do a get, watch, and a list. So basically making use of Kubernetes role binding, cluster binding, and you can connect uh, basically Kubernetes RBAC. So this brings us towards the last part of this Kubernetes 201 session, and this is securing your Kubernetes cluster. So the first part is why. Why do we need to secure a Kubernetes cluster, or are we really at a threat from a security perspective when using Kubernetes? So first, have a look at why. So this is again some insights or data that are collected by NewStack, and they have done a survey in terms of what are some of the top identified challenges for Kubernetes users across the globe. And as we can see that nearly 46% of the respondents have identified security as their main prime threat while using a Kubernetes cluster. So definitely that shows that we need some kind of a secured mechanism to ensure that our Kubernetes clusters and the applications running inside them are secured. And why this 46% respondents feel security as a prime challenge for Kubernetes? Now let's have a look at it. So this slide just gives you an example of some of the recently identified vulnerabilities across Kubernetes as a tool. They call it as CVE, or common vulnerabilities as exposure, in a security term. So if we just see, there is the first CVE 2018 100 to 105. They have a rating of severity in terms of 1 to 10. So anything being closer to 10 is a high severity rating. So this identified potential threat, or CVE, in Kubernetes had a high score of 9.8, which definitely means it was a very high severity threat to Kubernetes users, right? People who were using or running the Kubernetes clusters. Now this has been identified and patched in the latest releases and versions. So definitely no more potential threat. But then, yeah, there are many more which are mentioned on this page, right? So these are the vulnerabilities which are kind of known, have been identified and patched, but there could be many more which are kind of still unexplored and unknown to us. So a lot of unknown potential threats while using new tech tools and technologies like containers or Kubernetes, right? Nothing to scare you or dishearten you, but yeah, just to ensure that when you're using these new latest technologies, security also should be kept into mind. So from that perspective, let's have a look in terms of some of the best security practices that we should follow while implementing Kubernetes kind of a tool. So a couple of best practices mentioned over there. Upgrade to the latest Kubernetes version, right? Definitely a no-brainer. As we saw, of late, the older versions of Kubernetes have been identified with some of the vulnerabilities or CVEs, as we call them. So definitely upgrading yourself to the latest version, which is more secure and patched version, makes sense, until and unless you have a very strong compelling reason to use one of the older versions. And in case you are using one of the older versions, ensure that no vulnerabilities have been identified in that particular version or versions later on, right? Otherwise, the only option is to upgrade to the latest patched version and use it. Second point, disable public access to your cluster. This is again along the same lines of RBAC. So limiting access to your cluster, ensuring who has access in terms of resources and clusters, nodes. So definitely not everyone should have admin access and direct access to your Kubernetes ecosystem. Third point is use a bastion host. So definitely this again makes sense. So instead of teams or individuals having direct access to SSH into your Kubernetes nodes or cluster, use an intermediate bastion host or a jump server, as we popularly call it, right? This gives you an extra layer of security in terms of direct access. Out of the box, Kubernetes gives you something called as network policies, and we can use them to segment and limit container and pod communication. So definitely define network policies and basically have them defined in such a way that you can control container and pod communication. Again, Kubernetes gives us another tool or feature called as PSPs, pod security policies. So we can use pod security policies to prevent risky containers and pods from being used. So make use of pod security policies and define them. Since Kubernetes is based on container technology, right? And the most popular container tool right now is Docker. Most of the times, what happens is we tend to use a lot of images from different sources without authorizing them. So this wants to just want to call out on that point that use only trusted authorized container images. So there are a lot of third-party tools which are available in terms of security, and also Docker itself gives you a way or a method to identify trusted images. So always ensure that your trusted mode is on whenever you have a container image baked in, or you pull a container from a third-party repository. You verify that it's from a trusted source, and then only let that image enter your production or non-prod environments. Turn on audit logs. So definitely yes, Kubernetes gives you the functionality of logging. So enable logging or audit logs on your Kubernetes cluster. So in case something goes wrong, it's easy for you to identify what went wrong at what point of time. So logging help you over there. Secure your CI/CD pipelines. This is not only from a Kubernetes perspective, but more from a DevOps lifecycle perspective. Currently, most of the organizations across the globe are implementing DevOps, and definitely CI/CD plays an important role over there, right? All the continuous integration and deployment happening through pipelines. So if you're using some CI/CD mechanism like Jenkins or some other tool, ensure that security is baked into your CI/CD pipelines. You have a lot of again third-party tools which are available, which can do a lot of security scanning of what is running inside your CI/CD pipeline. And yeah, if it shows you a green signal over there, go ahead and deploy the code into your environment, production or non-prod. If you get a red signal over there in terms of a flag that has been identified, just fix it up and then redeploy. So I think those are certain best practices from Kubernetes ecosystem perspective that I wanted to share and wanted to highlight the vulnerabilities that have been identified, so that you have security also into your mind when you are trying to implement a Kubernetes kind of a system into your production or non-production environments. So that brings me towards the end of this session. And yes, thank you for being a lovely audience. You have my email and my Twitter link. You can follow up with me, and I'm open for queries. Thank you.